Hello students, good afternoon. You are welcome in the lecture number 8 of MHTCET for a chapter of chemical thermodynamics. In this lecture, we have to study some multiple choice questions of previous competitive exam, and the questions are based on first law of thermodynamics, enthalpy change, and the relation between heat of reaction at constant pressure and at constant volume. So let us see those expressions once again in short. We know first law of thermodynamics is stated in different manner. There are different statements of first law of thermodynamics. But in the first statement, energy can neither be created nor destroyed. Just one form of energy is converted into another form of energy, and the total quantity of energy remains constant because it is conserved. Secondly, we have studied energy of an isolated system remain constant. Third, energy of universe remain constant. Those are certain statements of first law of thermodynamics we have studied. The important statement is nothing but the mathematical statement. Formula for first law of thermodynamics. There you have studied if U1 is internal energy in initial state of the system, it get increased whenever heat is absorbed by the system. It also get increased whenever work of compression is obtained, and that is nothing but the final internal energy. So internal energy in the final state of system is nothing but internal energy in the initial state plus heat absorbed by the system plus work of compression. So U2 minus U1 become Q plus W, and this is a state function. Delta U is equal to Q plus W. Delta U is known as change in internal energy. It is state function. Q, heat absorbed by the system, plus W, work of compression. These two are path functions, but this is a state function, and the summation of two path functions is a state function change in internal energy is the mathematical formula of first law of thermodynamics. There you have seen the enthalpy. Enthalpy is a state function. Reactions are carried out at constant pressure and with a change in volume. So enthalpy is given by the equation H is equal to U plus PV. Here U is known as internal energy, or it is the unavailable energy to do work, and this is the available energy to do work. Summation of unavailable and available energy to do work is known as enthalpy. Since this is state function, this is state function, this is state function, therefore H is also a state function, and at constant pressure with change in volume, delta H, change in enthalpy can be calculated as delta H is equal to delta U plus P delta V. Then the relation, this is known as heat of reaction at constant pressure. This is known as heat of reaction at constant volume and P delta V is there. We know the general gas equation, ideal gas equation, PV is equal to nRT. So this P delta V can be replaced by delta nRT, and this equation becomes delta H is equal to delta U plus delta nRT, where delta N is nothing but N2 minus N1. N2 is number of moles of product in gaseous state. N1 is number of moles of reactant in the gaseous state. N2 minus N1, delta N is known as change in number of moles. It is the change in number of moles whenever reaction take place and reactants are converted to product. To calculate delta N, only number of moles in gaseous state are considered. So this is the relation between enthalpy of reaction at constant pressure and enthalpy of reaction at constant volume for a given chemical reaction. This is first law of thermodynamics, enthalpy, and the relation between enthalpy of reaction at constant pressure and at constant volume. One more equation we have studied for work done during a chemical reaction. Since we know dW is equal to minus P delta V, that P delta V is replaced by delta nRT. P delta V whenever replaced by delta nRT, this equation become work done during chemical reaction is equal to minus delta nRT. See the difference. Here is the summation. Here is a positive sign for delta nRT. Whenever we are studying the relation between enthalpy of reaction at constant pressure and at constant volume, and whenever we are calculating the work done during a chemical reaction, dW will be equal to minus delta nRT, because this is minus P delta V. Since this is a negative sign, this also become a negative one, and dW is equal to minus delta nRT is the work done during a chemical reaction. So that is there. That is what the point on the basis of which we have to see the multiple choice questions from previous examinations. So let us see the multiple choice questions from the exams, different exams. Already I have sent the questions from target book. We are using the target book where the questions are given from competitive exam, and those questions I am taking over here. Let us see question number 18 from target book. Question number 18 from the competitive examination. Internal energy does not include. Question number 18. Internal energy does not include. We know the internal energy. Internal energy is the summation of all various forms of energy associated with the system. So for a system, there are many forms of energy, like kinetic energy is there, like potential energy is there, like nuclear energy is also there. They are nothing but the internal energy. And here they have asked, internal energy does not include. 4 options given. First option is nuclear energy. Nuclear energy is the form of internal energy. Second, rotational energy. Rotational energy means kinetic energy. It is also the form of internal energy. Third, vibrational energy. We know vibrational energy is also a form of kinetic energy. And last is energy arising by gravitational pull. Energy arising due to gravitational pull. This is not internal energy. The energy arising due to gravitational pull is not the internal energy. So this is the correct option D. For question number 18, we have to identify internal energy does not include 4 forms of energy they have given, and which of them is not the form of internal energy, that we have to identify. So last option number 4th is correct. Energy arising by gravitational pull is not internal energy. Now question number 19. See question number 19. The internal energy change when a system goes from state A to state B. See the question. What is the question they have given? They have given a question for a reversible reaction. See here, the internal energy change when a system goes from A to B is 40 kilojoule per mole. They have given like this. System goes from A to B. At that time, change in internal energy is 40 kilojoule per mole. Now, if the system goes from A to B by reversible path and return to state A by an irreversible path, what would be the net change in internal energy? Whenever A converted to B by reversible path, A to B, change in internal energy is plus 40 kilojoule, plus 40 kilojoule. Now B is converted to A in the irreversible manner, means B is converted to A by minus 40 kilojoule. So what is the net change in internal energy? Plus 40 and minus 40, 0. Now they have given 4 options. Option A is 40 kilojoule, B greater than 0 kilojoule, C less than 40 kilojoule, and option D is 0 kilojoule. So last option is correct. You got it? Whenever A is converted to B, change in internal energy is plus 40 kilojoule. B is converted to A, at that time change in internal energy will be minus 40 kilojoule. So net change in internal energy is plus 40 minus 40, that is equal to 0 kilojoule. So option D, option number 4, last option is correct. Next question number 20. Which of the following expressions represents the first law of thermodynamics? They have given different expressions and they have asked which of the following expressions represents first law of thermodynamics. Just now we have seen the explanation. Delta U will be equal to Q plus W, where Q is heat absorbed by the system, W is work of compression. Both are path functions, but their summation is change in internal energy. It is a state function. Summation of two path functions is a state function, and this is the mathematical equation of first law of thermodynamics, and that we have to identify. 4 options they have given. First option, delta U is equal to minus Q plus W. Second, delta U is equal to Q minus W. Third, delta U is equal to Q plus W. So option C is correct. Option number C is correct for question number 20. Now question number 21. Mass and energy are conserved. It is demonstrated by. Question number 21. Mass and energy are conserved. See, we have seen the first law of thermodynamics, and first law of thermodynamics is stated as a law of conservation of energy. First law of thermodynamics is also known as law of conservation of energy. That is, energy can neither be created nor destroyed. Just one form of energy is converted into another form of energy. But whenever one form of energy is converted to another form of energy, we know that according to Einstein's equation, energy is equal to h nu. Energy is equal to h nu. Or energy according to Einstein's equation is equal to mc square. Energy is nothing but mc square. See this equation. Energy and mass are interconvertible into each other. Energy and mass, they are interconvertible into each other. Means certain loss of energy is there. So where that energy goes, that is converted into mass. So totally energy is not converted from one form to another form. Certain energy loss may be there, and that energy loss is converted into mass. Therefore, energy of system plus mass of system remain constant. Conservation of mass and energy take place. That is the modification of first law of thermodynamics. And here they are given that one, mass and energy are conserved. It is demonstrated by option A, first law of thermodynamics, no. B, law of conservation of energy, no. C, law of conservation of mass, no. Last, modified form of first law of thermodynamics, that is correct. It is the modified form of first law of thermodynamics, because certain energy is lost. According to Einstein's equation, energy and mass are interconvertible into each other. Whatever the loss in energy is there, that is converted into mass. Therefore, the conservation of only energy is not possible for a system, because certain loss is there. So it is considered as the summation of mass and energy remain constant. Summation of mass and energy remain constant, and therefore that is the modified statement of first law of thermodynamics. Conservation of mass and energy take place. For question number 21, last option D is correct. Now question number 22. How internal energy will change due to removal of heat and work from the system? Question number 22. How internal energy will change due to removal of heat and work from the system? See, this is important question. Change in internal energy. First law of thermodynamics. According to first law of thermodynamics, delta U will be equal to Q plus W. They have asked, what is the change in internal energy taking place? Whenever heat is lost by the system and work is done by system to the surrounding. So this is the equation on the basis of sign conventions. Sign conventions are important. Here we know plus Q is the heat absorbed, minus Q, it is the heat lost or heat released, plus W, work of compression. It is the work of compression, that is work done by surrounding to system, and minus W, it is the work of expansion, that is work done by system to surrounding. Now what is this? Question number 22. We have to find out the value of delta U. Whenever heat is lost by the system, means Q is minus. So delta U will be equal to minus Q. Heat is lost and work is done from system to surrounding. System to surrounding means work done is also negative, minus W. This is minus, this is also minus. Their summation comes to be negative. Therefore, change in internal energy is negative. You got it? Change in internal energy will be negative because Q is negative, W is also negative, and therefore their summation is negative. There is not multiplication. There is the summation between Q and W. See here, here is a summation, not multiplication. Therefore, the summation of Q and W comes to be negative. Therefore, delta U negative means increases or decreases? Decreases. So, let us see the options. Option number A, decrease. B, increase. C, remains same. And D, none. Therefore, option number A is correct. Now, see question number 23. See, all these are the questions from different exams. All of them, these are the questions from different examinations. They may be questions from MHTCET, they may be questions from AIMS CPMT, CBSE PMT, or something exam, competitive exam. So be careful for these questions. Now question number 23. Which of the following has no change in internal energy? Which of the following will have no change in internal energy? This is the first law of thermodynamics equation. We have seen 7 type of processes: isothermal, isobaric, isochoric, adiabatic, cyclic, reversible, irreversible. There we have seen that isothermal processes are the processes which are carried out at constant temperature. Isothermal processes carried out at constant temperature. So T1 is equal to T2. Therefore, change in temperature is 0. And temperature directly affects the magnitude of internal energy. Therefore, for isothermal process, delta U is also equal to 0. Means change in internal energy is 0 for which type of the process? Isothermal process. For isobaric process, delta P is 0. For isochoric process, delta V is equal to 0. For adiabatic process, Q is equal to 0. And for isothermal process, delta U and delta T are 0. So let us see the options. Question number 23 is which of the following has no change in internal energy? Option A isobaric, B isochoric, C isothermal, and D adiabatic. So option C is correct. Isothermal. Isothermal processes are the processes which are carried out at constant temperature. Change in temperature is 0 and change in internal energy is also 0. Now see question number 24. in an isothermal process. The process is isothermal. So what is 0? We have studied delta U is 0 and delta T is 0. So see the options. Option A, Q 0 and delta U 0. Is it true or false? False. Because for isothermal process only delta U is 0 but Q is not 0. Q is not 0. So see the option. Option B, Q is not 0 and delta U is equal to 0. So B is right. For isothermal process, delta U is 0 and Q is not 0. Therefore, second option they have given, option B is correctly given. Now question number 25. See question number 25. Which of the following is equation for first law of thermodynamics when the process is adiabatic? First law of thermodynamics, delta U is equal to Q plus W. They have asked which of the following is equation for first law of thermodynamics when process is adiabatic, and we know for adiabatic process Q is equal to 0. Therefore, what is the equation left behind? Delta U is equal to W. So this is the equation for adiabatic process. So see the options. Option A, Q is equal to delta U plus W, wrong. B, Q is equal to W, that is there. No, Q is equal to W, that is also wrong. C, W is equal to delta U. W is equal to delta U. This is correct. Because for isothermal process delta U is 0. For adiabatic process Q is 0. Isobaric process delta P is 0. Isochoric process delta V is 0. Here they have given the adiabatic process, so Q is equal to 0 and delta U is equal to W. Option C is correct. Option C is indicated like that, W is equal to delta U. Now let us see question number 26. The process in which work is done at the expense of internal energy is. In which process the work is done at the expense of internal energy? See, work is done at the expense of internal energy means this is the equation we have to obtain. Work of compression increase in internal energy. You got it? Plus W plus delta U means work of compression increase in internal energy. That is work done by surrounding to system. Here work is done by system to surrounding. At that time this will be minus delta U means decrease in internal energy. Work done by system to the surrounding. So work is done at the expense cost of decrease in internal energy. So it is the adiabatic type of process. See the options. First, isothermal, isobaric, isochoric and adiabatic. So out of the 4 options, which is correct? Option B. Under adiabatic processes, change in internal energy decreases and work of expansion is obtained. Question number 27. See question number 27. In a closed insulated container, a liquid is stirred with paddle to increase in temperature. In this process, which of the following is true? See, the apparatus is insulated. In the insulated apparatus, neither heat flows from system to surrounding nor from surrounding to system. Therefore, Q is equal to 0. It is nothing but the adiabatic process. Insulated container means adiabatic process. Q is equal to 0. And whenever Q is equal to 0, delta U is equal to W. But certain quantity of work is obtained, either a positive work or a negative work. Therefore, this work is not 0. See, this is important. As the apparatus is insulated, change in heat is 0. No loss of heat or gain of heat take place. Q is 0. So this equation become delta U is equal to W. It may be plus W or minus W. If delta U is minus, work done is minus. Delta U is plus, work done is also positive. So work done is not 0. So see the options based on that. Option A is delta U is equal to W is equal to Q is equal to 0. That is wrong. Second, delta U is equal to 0. That is wrong. Third, delta U is equal to W is not equal to 0 but Q is equal to 0. So option C is correct. Now question number 28. Mathematical equation of first law of thermodynamics for isochoric process is. For isochoric process now. What is isochoric process? The processes which are carried out at constant volume are known as isochoric processes. Delta U is equal to Q. W is nothing but minus P delta V. Isochoric process delta V is 0 and delta U will be equal to Q. Because for isochoric processes which are carried out at constant volume, change in volume is 0. If this is 0, total factor will be 0. Therefore, delta U is equal to Q is the equation for isochoric process of a first law of thermodynamics. So see, option A is correct only. Delta U is equal to Q at constant volume. Option A is right. Now question number 29. A system absorbs 600 joule. System absorbs 600 joule of heat and equivalent of 300 joule and work equivalent to 300 joule on its surrounding. Change in internal energies. Very simple. System absorbs Q 600 joule. It does the work of expansion system to surrounding means minus 300 joule. So calculate the change in internal energy 600 minus 300. So delta U will be equal to 300 joules. Very simple. Since heat absorbed is given, since work done by system to surrounding is given, that is the work of expansion. So take it as negative. 600 minus 300, change in internal energy will be plus 300. 4 options they have given. Option A 300, B 400, C 500 and D 600. So option A is correct. That is 300 joules. Now question number 30. Enthalpy H is equal to. Enthalpy H is equal to. We have seen the equation of enthalpy, which is a state function. H is equal to U plus PV. This is internal energy and this is PV type of energy. Unavailable energy to do work and available energy to do work. Summation of unavailable and available energy to do work is known as enthalpy. So see the options. Option A, internal energy. B, product of pressure P and volume of gas. C, internal energy U plus PV. Internal energy U plus PV. So option C is correct. Enthalpy is a summation of internal energy U and PV. Now question number 31. Question number 31. Correct representation of heat supplied at constant pressure and constant volume in gaseous reaction is. Correct representation of heat supplied at constant pressure and at constant volume in gaseous state reaction is. See, this equation I have told you, delta H will be equal to delta U plus delta nRT. That is the equation. Further, if we split it, this become H2 minus H1. This will be U2 minus U1 plus this is delta N means N2RT minus N1RT. Delta N is N2. N2 minus N. Let us write one more step. Delta N is nothing but N2 minus N1 RT. Solving that, it becomes H2 minus H1 is equal to U2 minus U1 plus this N2 RT minus N1 RT. That is the equation. Now on solving this, see what it become. H2 minus H1, U1 taken on left side plus U1, this taken on left side minus U2, that is equal to N2 RT minus N1 RT. So this is the final formula. Now let us see 4 options and which of the option is correct. Option A, H2 minus H1 plus U2 minus U1. So this is not like that. First is not correct. Second is H1 minus H2. They have given. Now H1 minus H2, that is also wrong. Third option, H2 minus H1 plus U1 minus U2 equal to N2 RT minus N1 RT. So option C is correct. Third option is correct. Now question number 32. The relation between delta U and delta H. Relation between delta U and delta H. That is the change in enthalpy. Delta H is equal to delta U plus P delta V. This is known as equation of enthalpy change during a chemical reaction. So out of the 4 options, let us see which option is correct. Option A, delta H is equal to delta U minus P delta V. They have given, but minus it is not there, it is plus. Now second option, delta H is equal to delta U plus P delta V is given. So second option they have given like this. Therefore second option B is correct. Now question number 33. Question number 33. Which one is correct? They have given 4 options. Delta H is equal to delta U plus RT delta N. Delta U is equal to delta H plus P delta V. See, simply it is the equation they have given direct format. Delta H is equal to delta U plus RT delta N. Means delta N RT one and same. So option number A is right. First option is correct for question number 33. Now let us see question number 34. Question number 34. which of the following equations show the relationship between heat of reaction at constant pressure and at constant volume? This is the equation showing heat of reaction at constant pressure and this is heat of reaction at constant volume. So that equation is delta H minus delta U is equal to delta nRT. This equation is written like this also, where delta H is heat of reaction at constant pressure, delta U is heat of reaction at constant volume. So this is the relation between enthalpy of reaction at constant pressure and at constant volume. So which equation is correct? Over here they have given 4 options, in which this is the option D. So 4th option is correct. Now question number 35. See question number 35. Question number 35 is, which of the following statements is true? Delta U is always greater than delta H. Delta U is less than delta H. Always less than delta H. Delta U may be lesser or greater or equal to delta H. And delta U is always proportional to delta H. Now see, this is important to see the relation between delta H and delta U. See, important one. Delta H we know equal to delta U plus delta nRT. Right, this is the equation. If we have this reaction, carbon monoxide gas plus half O2 gas giving CO2 gas. What is delta N? Delta N is 1 minus, this is 1.5. So it is equal to minus 0.5. Delta N is minus 0.5 this reaction, for this reaction. Is it right? Now if we substitute here minus, what it become? Suppose if this is 100, this is minus sign. So if this will be 10, whole factor is 10. What is this? It is 110. So in this case, delta H is less than delta U. Delta H is less than delta U. Why? Because N2 is less than N1. Number of moles of product is less than the number of moles of reactant in gaseous state. At that time, delta H is less than delta U. Now see the another reaction. Suppose, let us see one reaction in which now delta N is positive. CaCO3 solid giving CaO solid plus CO2 gas. What is delta N for this reaction? 1 minus 0. 1, because this is 1. Only gaseous state we have to consider. Only gaseous state. So 1. What is N1? 0. This is solid. So not considered. 1 minus 0. Delta N will be equal to 1. Now, since delta N is 1, this answer will be plus. So, if delta H is 100, here delta N plus means if that answer comes to be 10, at that time this will be 90. So, here delta H is greater than delta U. What is the criteria for that? The criteria is N2 is greater than N1. So whenever N2 is greater than N1, at that time delta H is greater than delta U. Whenever N2 is less than N1, at that time delta H is less than delta U. And when they are equal, whenever this is 0, whenever this becomes 0, means number of moles of reactant is equal to number of moles of product. Whenever delta N is equal to 0, means number of moles of reactant is equal to number of moles of product. At that time this becomes 0 and delta H is equal to delta U. Those are the three conditions, three important conditions, and on the basis of those conditions, here are the questions. So question number 35. Which of the following statements is true? Option A, delta U is always greater than delta H. Is it always greater? No. Sometimes it is less also. C, second option B, delta U is always less than delta H. Is it always less? No. Sometimes it is greater also. Option C, delta U may be less, greater or equal to delta H. That is right. Here delta U is greater, here it is less, and whenever this is 0, at that time delta U and delta H are equal also. So option C is correct. Now question number 36. If delta H is the change in enthalpy and delta U is the change in internal energy accompanying a gaseous reaction, again find out the relation. Delta H and delta U relation. So what is the relation I have explained here? Whenever delta N is negative, means N2 is greater than N1, product moles are greater than the reactant moles. At that time delta H is less than delta U. Now see the options. Option A, delta H is always greater than delta U, that is wrong. B, delta H less than delta U only if number of moles of product greater than the number of moles of reactant. Is it greater or less? It must be less. So B is wrong. C, delta H is always less than delta U, that is also wrong. Last option is correct, that is delta H is less than delta U whenever number of moles of product is less than the number of moles of reactant. Number of moles of product is 1, reactant is 1.5, this delta N is minus, therefore this will be minus, so delta U is greater than delta H, or delta H is less than delta U whenever number of moles of product is less as compared with the number of moles of reactant. So last option B is correct. See one more question, 37. At constant temperature and pressure, which of the following statement is correct for the reaction? This same reaction they have given. This is the reaction they have given, CO plus half O2 giving CO2, and for this reaction what is the relation between delta H and delta U? See, we have studied. For this reaction delta N comes to be negative, therefore what is the relation? Delta H is 100 and delta U is 110, means see here it is delta H is less than delta U for this reaction. Now see the options. They have given 4 options. Option A, delta H is independent of physical state of reactant and that of compound. No, it is not correct. B, delta H greater than delta U, that is wrong. C, delta H is less than delta U, that is correct. So option C is correct. So these are the multiple choice questions. We have covered almost 20 questions we have covered in this lecture based on first law of thermodynamics, enthalpy, and the relation between heat of reaction at constant pressure and at constant volume.